I made this right here on my desk with the upcoming Makera Z1 Mini CNC machine. Today we're taking a first look at its specs and features, doing some heavy milling tests and diving into a demanding aluminum project from a high-speed 3D printer. Ultimately we'll answer the question, is the smaller Makera Z1 worth the Kickstarter gamble? Let's get those chips flying today on 24/7 Printing. By the time you watch this video, the Kickstarter crowdfunding campaign for the Makera Z1 has launched, and some of you might be wondering, who is Makera? Makera is a Chinese-based manufacturer of entry-level desktop CNC machines. In 2021, they successfully finished their first Kickstarter campaign for the Carvera flagship machine. Key features: automated tool changing, integrated vacuum, servo motors, full enclosure, and it's ready built at high quality. I made a video about my first steps into CNC milling with the Carvera a while back, and I was impressed about how well Makera guides newbies, like I still am, into the topic of working with all sorts of materials, including PCB making and aluminum milling. The fully featured Carvera isn't exactly cheap, therefore many wished for a cheaper option to get into CNC machining. Makera listened and delivered. The slightly stripped down Carvera Air was their second successful Kickstarter campaign last year, and they even doubled the success of the original Carvera. Long story short, Makera has a good track record concerning Kickstarter, and they delivered. Their new Z1 goes one step further in this direction, aiming at lower pricing. For around $800, you can back this machine and you can save a good chunk of the MSRP. That lower price tag also comes with lowered specifications and a smaller build volume, but also with some novelties their flagship models don't even have. Makera sent me a late-stage prototype of their Z1 to try it out. I took the chance to design and fabricate a small but rather complex aluminum part using Makera's software solution Makera CAM. And a quick disclaimer, no money changed hands, and Makera has not seen this video beforehand. The goal of this video is to check how well the new Z1 works for a rather demanding aluminum project, including a lot of CAM toolpaths to be handled. Today this is not a full review, as firmware, software and some hardware are at the prototype state and my time with the machine was limited. We have a brief look at the package, we compare the Z1 to the Carvera machines, and we'll go step by step through my project, which I intentionally set as a little challenge for myself and the Z1. Ultimately, we discuss this Kickstarter campaign. Is this one worth the Kickstarter gamble? This time, I'll have a clear recommendation. Alright, bring it on! Let's go briefly through the unboxing, as what I received is not the final package. On the Kickstarter page, linked in the video description, you'll get more detailed information on that. First of all, the box and the machine themselves are rather lightweight in comparison to their larger machines. Most people won't have problems lifting it alone. The machine is around 17 kilograms. After unwrapping, I realized a lot of aluminum chips throughout the package. Good for me, this machine has been tested beforehand, probably meaning less unpleasant surprises. The first box included aluminum chips as well, bit colors and a lot of bits. And yeah, we will use a lot of them. There was also a range of materials, which is great, but we'll focus on aluminum today. The other softer stuff is less of a challenge anyway. The laser add-on is also a standard accessory for Makera machines. Blue diode, 445 nanometers and at 5 watt power. Good for wood, opaque plastics and PCBs. Due to software limitations, I didn't use the optional 4th axis. Another box included what seems to be the standard tools and materials package. Just like with the Carvera, you'll have everything to get started, from M5 screws to dowel pins, clamps, tool bits, safety goggles, the emergency switch and an XYZ probe. You'll be able to start right away, but from my experience you'll want and need more tools at some point. What wasn't ready yet were the instructions and the examples guide. And this will be good, as it likely will be at high quality as for the Carvera machines, providing an excellent start into the topic with examples and detailed guidance. Newbies don't have to worry. Makera also sent their Cyclone dust collector, basically a filtered external vacuum for the Carveras and the Z1, which can be controlled by G-code, and it should be way more silent than the usual shop vacuum. Let's have a closer look at the Z1 and compare it to Makera's other two machines. First of all, size, build space and weight are obviously way more compact than the other two. Also, spindle power is reduced to 150 watts and can go at a max of 13,000 RPM, like with the Carvera Air. By default, all Makera machines come with 1/8 inch spindle collets. Optionally, there are other sizes available as well. For my aluminum project, I used a larger 6mm one to be able to make nicer and faster faces. Tool changing on the Z1 is done manually and it's quick. I didn't miss the automated tool changer of the larger Carvera much, but if a lot of tools are involved, like in today's project, you'll need to plan carefully. On the Carveras, the cooling can be air assisted and you'd actually need an external air compressor to get the debris out of the way and to cool your tool. The Z1 actually is a step forward here. It has a rather powerful fan at the top which blows through the spindle down to the tool and stock, which keeps the build area mostly free of dust and debris. Both the Carvera Air and Carvera use a dust tube for dust collection, whereas only the original Carvera features an integrated vacuum for this. All machines support external solutions for dust collection, like Makera Cyclone, or you can just connect your shop vacuum. In comparison to the larger Carveras, the Z1 use open-loop stepper motors, regular Acme lead screws, and common 12mm linear rails. Spindle runout is the same, specified resolution is lower. A novelty on the Z1 is the integrated camera, though throughout my testing it couldn't be used yet. Connectivity is the usual for all three. Makera provides their own controller and cam software, but they have bigger plans for the end of the year. A new Makera Studio software including cam and more, a controller app, AI-supported design, and Makereables, a platform to share designs. Huge plans. We'll see if they can succeed there. I hope they will improve their cam software, as there are some rough edges here and there. Alright, let's dive into aluminum machining with the compact Z1. Before we get into that, the latest news and offers from today's sponsor, PCBWay. First, their mascot 3D printing design contest is still open for you to participate. You can submit either a design based on their mascot Eon or your own original character, and winners receive cash prizes. First place gets $500, plus coupons and certificates. Shortlisted designs may even be professionally 3D printed or featured. Second, throughout September and October as well, PCBWay is still offering their purple solder mask at no additional cost. That means you can add visual flair to your PCBs without paying extra. Check out the link below and visit PCBWay.com. Before we start, a quick note. I still consider myself a beginner in CNC machining and I have huge respect for all the pro machinists out there. If you have hints, remarks or any other comment on what I'm doing, go for it. I love to read your comments, I'm open for constructive criticism and as always I'll try to reply. The comments on my Carvera video were awesome. I was able to learn a lot from those and connected to some of you. With the Z1, I want to make an aluminum toolhead plate for my 24/7 Zero, my high-speed take on a Warren Zero do-it-yourself printer from 2023. So it's a bit dated and it's time for improvements. The plate I designed has a lot of interfacing and therefore various hole sizes. 2mm holes for the linear rails, 2.5mm ones for attaching the hot end, 3mm for the belt retention block, and so on. We'll also make a machined M3 thread at the front to mount a Bowden adapter. Yes, this machine is lightweight and Bowden. I also wanted some pockets to emphasize the lightweight approach of my speed concept, and I don't know why, but I have an obsession for chamfers, so those are also part of the game, as well as double-sided machining, on which I failed during my Carvera project last year. Functionally, for sure, some of that stuff is not necessary, just like the chamfers, maybe the pockets and the double-sided machining, but I wanted the challenge. For me, the Z1 and the software. Anyway, the Makera Z1 is new to me, and as a Fusion 360 cam user, Makera Cam is new to me as well. So I decided to do some test runs for the features we'll have for the project, and I was keen on testing a larger 6mm single flute end mill. I had zero clue on how this one would perform on the entry-level Z1. With a bit of AI help, I defined 4 test runs for this tool, varying feed rate, RPM and step down, and yeah, I was a bit ambitious with the faster and aggressive ones, as we'll see. I went with a 3D step file with 4 pockets on the stock. For each pocket I defined a specific tool with the varied parameters. For pockets like these, Makera's cam is straightforward. If you have problems or questions on 2D or 3D toolpaths in Makera Cam, there are quick and concise videos on Makera's YouTube channel dedicated to each one. Jason has great pacing and good depth on these rather short videos, so no typical YouTuber blah blah. straight to the point. First, the Z1 needs a basic setup for clamping and reference. As mentioned, all the basic stuff to get started with projects are always included with Makera's machines. Like the L bracket for referencing and aligning, clamps, bolts, dowel pins, and of course some bits. As I wanted to cut more material faster and to have nicer surfaces for facing than with the included smaller end mills, I ordered that 6mm single flute end mill at Amazon for around $10 each. Link below. I'm happy with that one, even though it's a bit long at 22mm. The needed 6mm color is optional and available directly from Makera. And yeah, I was ready, the Z1 was. I made myself a nice but cold workspace in my garage. I didn't need compressed air, by the way, due to that cooling fan on the toolhead, as you'll see. Setting up and starting the process in the controller software is rather easy as well. You'll get introduced to this, like on the Cavera, with the example projects. As an insurance, there's also an option for scanning the toolpath to prevent crashes beforehand. Set probing, auto leveling, alright, let's go. I admit it, I am an emotional guy and I was totally hooked throughout this project, and yeah, look and listen. The save run seems low effort for the Z1, great stuff. Also watch the top spindle fan kicking in. And how the chips get vibrated to the rear where the vacuum collects at least some of them beforehand. At 0.8mm step down, the machine sounds more tortured. Listen. It finished though. That fast 1.2mm step down profile I defined was a different story. Ramping and stop. That was too much for the 150-watt spindle, not enough torque for this. So probably somewhere between 0.5mm and 0.8mm step down is reasonable for this setup. As I had only one try for my project time-wise, I went for the save profile, as that's fast for my concerns already, even though surfaces were still nice at 0.8mm step down, as we see. We look at accuracy later. 0.02mm resolution is theory and marketing, not reality, just to be clear. I am German, you might hear it, sorry, and I don't like unpleasant surprises. So I briefly pre-tested some other tools and toolpaths with the Z1 and Makera Cam beforehand. 2 drilling operations, a contour operation for a bigger hole, chamfering those holes, and cutting one M3 thread. We'll do that on the real part as well. Long story short, drilling, contour, chamfers, and the M3 thread. All worked great, we are set up. The part I wanted to make is 3mm thick, so I thought it might be a great idea to just make a suitable and exact stock beforehand out of 100 by 100 by 5mm raw material. The idea is to attach it to a polycarbonate wasteboard and to machine holes for the 4mm dowel pins included for exact positioning after turning the stock around. Making the polycarbonate wasteboard was easy. First, laser cutting an MDF wasteboard and machine the PC board to size and function in the Z1. I used the 6mm end mill for 2 types of faces on both sides. And the 1/8 inch bit for the contours, cutting it to exact needed size. And oops, seems that I forgot to add tabs or Makera Cam didn't process those, who knows. And yeah, this 6mm end mill was a great idea. Thickness is within the limits of the machine, as you see from the measurements on various locations here. And there we have a polycarbonate wasteboard and my machine stock. I measured the following deviations for the contours. Both contours were cut with a thin and rather long 1/8 inch tool without any finishing passes. What do the machining pros say to the accuracy here? Leave a comment. But I had another problem. I had forgotten about any means to align and clamp the alu part to the PC wasteboard for machining the first side of my part. Eventually I came up with the following procedure. I used a 3D printed part for alignment and used clamps to hold it down. By the way, I had to set 0 of the new work coordinate system with the laser pointer of the probe, as that new and promising probe rod didn't work for me, unfortunately. Makera sent out a new one, but it didn't arrive in time. Can't wait to try this, as it allows direct measuring without that clunky thing of the Carrera. So I drilled 2.5mm holes through both alu stock and PC wasteboard. I used the M3 threading tool to cut threads into the polycarbonate. Drilled out 3mm through holes on the alu stock, and bingo, I was able to properly clamp the custom stock to the PC wasteboard using low profiles M3 bolts. Very satisfying result before even machining the real part. Setting up the CAM program made me realize though, okay, that's getting out of hand. 7 tools, 11 paths, and that's only on the first side. No room for error, no second try possible. Double checking, triple checking, and wishing for a toolpath simulation like in Fusion 360, which Makera CAM doesn't have, unfortunately. We'll see what their new Makera Studio brings to the table end of the year. Anyway, let's do this. Auto leveling, drilling 2mm holes, 3mm holes, 2.5mm holes, quickly tool changing in between, and here I wished for a more detailed prompt with naming the tool. Then we make an M3 thread at the front, the pockets with a fine 1mm end mill, pockets on the through holes, a 4mm hole for the Bowden tube, a contour cut halfway through, 4mm holes for the dowel pins through the alu stock and the PC wasteboard to align the stock after turning around, and the chamfers everywhere. Quality check. Looking great. Except for those fine chamfers on the straight contours. Wasn't sure why at that point, so I didn't machine those on the bottom side. After watching Jason's video on chamfers with Makera's CAM, I should have set an offset there, right? But I'm super happy with the result. Also, the double-sided clamping and aligning methods seem to work. The chamfers on the through holes, initially drilled from the top side, are perfectly centered. Also, a quick test fit on the printer came out nicely as well. The holes, the threads, everything aligned, 0 complaints, this works. By the way, those fins on the printed part are for science. Can't wait to operate this setup soon. Make sure to subscribe on all my social media channels. And don't forget to hit the like button for this video. Done? Alright, let's sum up my experience with the Z1 and evaluate this Kickstarter campaign. Should you back this one? Using the Makera Z1, I had to rely on beta hardware and beta software to finish a project in time. There was 0 margin for error. And again, that's not a review, as my machine isn't a finished product yet. Call it a first look, or a first user experience, or whatever. Though this worked out well for me. I was prepared for the worst, to be honest, but in the end I was totally hooked for some days straight and I had a lot of fun with my project. Except for that new and promising probing rod, I didn't experience any hardware flaws. The machine did exactly what I wanted and what I planned. And all within the expected margin of accuracy, taking into consideration what the Z1 actually is. An entry-level desktop CNC with a 150-watt spindle on linear rails, driven by Acme lead screws on regular stepper motors. For rather complex but casual machining at default settings for the tools I used in my project, the stripped-down motion system wasn't actually a limit. Spindle power isn't plenty. If you want more, you'd need to spend more money and or go the do-it-yourself route for this. Meaning, spending hours of building, calibrating, tweaking, upgrading and so on. This can be a lot of fun and also very rewarding, but also devastating at some point if you're not prepared for a rabbit hole like this. Looking at the list of my negatives though, there isn't too much to complain. I noted no way to attach a tablet or something to the machine like on the Carveras. Also, there is no offline controller like on other machines. The linear rails are exposed to the debris, which might be concerning. Makera sent out dust caps for the holes though, and they will come with the finished product. Firmware and software were a bit rough at certain functionalities during my testing. The chamber camera didn't work at all and connectivity was very limited. No USB and only the direct Wi-Fi connection was possible. Also, file upload was annoyingly slow. And that's it, nothing severe which couldn't be solved within some weeks or months. At the time writing the script, Makera sent out a firmware and controller update, addressing all the software issues already, though too late for my testing unfortunately. But let's address the elephant in the room, Kickstarter. Love it or hate it, many companies simply use it as a marketing platform. Backers can benefit from huge discounts though, when early backing. Backing is a gamble, as there is zero guarantee to even receive a product. If you're interested in backing, have a close look at the company and their latest products. My impression on Makera and the Z1, flawless track record on Kickstarter, and the Z1 already worked very well for my purposes. Recommendation: if you want a hassle-free and convenient CNC machining experience, ready-built, enclosed, and with a lot of guidance from manufacturer side, go for it if you don't need huge build volumes. Doesn't matter if you're a bloody beginner or experienced machinist who wants a little machine on the desk. Take that discount they offer and you'll receive it earlier than regular orders at MSRP. If I could help you finding a decision on this, consider using my link to the Z1 Kickstarter campaign in the description. This makes these videos possible at zero cost for you. Thanks for watching, servus and bye bye. Thank you, Shulo!